Zero is my hero.
Welcome to the adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl like PreCalculus and the Daring Derivative.
Counted on our fingers and toes. Now you're here to stay.
Alright, we're going to be doing radian measure. Radian is another unit of degrees. It is just another unit to measure angles. Just as we can measure a distance in feet, we can also measure it in inches or centimeters or meters. There's just different units to measure a distance. The same is true with measuring degrees or measuring angles. We can measure it in degrees, or we also can measure it in what's called radians. By definition, 1 degree is equal to pi over 180 radians. Okay, so let's just think of this way. If I multiplied both sides by 180, so if I multiplied this by 180 and then multiplied 180 over here, my 180s cancel, and basically I have 180 degrees equals pi radians. Normally when you're using radian degrees or radian measurements, skip what I just said. You don't put radians and degrees in the same sentence. When you're using radian measurements, you actually drop the word radians. Okay, so I'm just going to put it this way. 180 degrees equals pi. So if you come over here to your quadrants, and remember we measure our angles going in a counterclockwise direction. 0 starts here, 90, 180, 270. Well, so if 180 degrees is the same thing as pi, this 180 degrees is the same thing as pi radians. Anytime you see the word pi dealing with the measuring of an angle, you automatically know it's radians. Okay? So, if 180 degrees is pi, what would 90 be? 90 degrees is half of 180, so then it would be half of pi, but we call it pi over 2. We don't say 1/2 of pi, we say pi divided by 2. So if going from 0 to 90 is pi over 2, that's 1 quadrant. So if we go 1 quadrant, 2 quadrants, 3 quadrants, then 270 would be 3 times pi over 2, or we call it 3 pi over 2. You don't normally see it as 3 halves pi. The pi will always be in the numerator. So you call it 3 pi over 2. This is also 0 degrees. It's also the same thing as 360. 360 is 2 times 180, or 2 times pi in radians. So just your basic 0, 90, 180, 270 in radians is 0 pi over 2, pi, 3 pi over 2, 2 pi. 2 pi being the same as 360. So we're going to work on converting back and forth from degrees to radians. So look at 15C1. So essentially what we've created is we've created a conversion factor of pi is the same thing as 180 degrees. If you can just remember, pi is 180 degrees, that's your conversion factor. So we want to change 320 degrees into radians. Just like any other conversion factor we've done, put it over 1. You're going to multiply by a conversion factor. If degrees is in the numerator here, degrees has to go in the denominator, so it will cancel. Then we use our conversion factor, so then we know 180 degrees is the same thing as pi. Okay, so our degrees cancel, so then we have 320 pi. Your degrees canceled, remember. Pi shows you your unit as radians, but we just don't write the word radians. Okay, so now this just becomes a fraction to reduce. Both of these can be reduced by 10, which basically makes those zeros go away. So that would be 32 pi over 18. We can still reduce more. Can reduce by 2, can reduce by 4. I don't think 4 goes into 18. So if we reduced it by 2, then that would be 16, and reducing 18 by 2, that would be 9, and that doesn't reduce anymore. So 16 over pi, that would be your final radian answer. 16 I said 16 over pi. 16 pi over 9 is the same thing as 320 degrees. This one is just in degrees. This is in radians. Again, we don't put the word radians. Seeing the pi there tells me that it is in radian. 15C9 correlates with 15C1. It says to put the decimal of the radian that we just calculated up here. So we need the decimal equivalent of 16 pi over 9. When you want the decimal equivalent, all you're doing is changing pi into 3.14. So to get the decimal equivalent, really what you're doing, 16 pi means 16 times pi. Change pi into 3.14. Pi is the same pi. And then divide it by 9. So when you go and do that, 16 times 3.14 and then divide it by 9. And in the book they're asking you put it to 3 decimal places. So that would be 5.582. Okay, look at 15C4. We have negative 60 degrees. Remember, when you see a negative, it just tells you which direction you are rotating. Negative means we are rotating in the clockwise direction. So it doesn't really affect your conversion at all. It just means when you convert it to a radian measurement, you're going to have a negative in front of it. So we start with negative 60 degrees, put it over 1. We're going to multiply by our conversion factor. We want degrees to cancel, so our degrees has to be in the denominator. 180 degrees is the same thing as pi radians. So now our degrees cancel, and then your negative stays. Negative times a positive is a negative, so negative 60 pi over 180. Your pi tells you the units, that it's radians. So we can reduce both of those by 10. So that would be negative 6 over 18. We can reduce those again by 6. So this would be negative. You could put the 1 there, but you don't have to. So normally you'll just see it like this. Negative pi over 3. So negative pi over 3 is the same thing as negative 60 degrees. The negative just tells you which way you are rotating. Okay, now looking at 15C12, that correlates with 15C4. In 15C4, we found that the radian was negative pi over 3, and now in 15C12, they're wanting you to find the decimal equivalent of negative pi over 3. So all you're doing is changing your pi to 3.14, dividing it by 3, and then do that to 3 decimal places, and that would be 1.047, and you still have your negative. Okay, so don't lose the negative, because that's basically negative pi, negative 3.14. Okay, let's look at 15D7. In 15D7, you are wanting to, they're asking you to go from radians to degree. Okay, so they have given you 13 pi over 18. So when we need to convert that to a degree, so it's already in fraction form. So now I just need to multiply by a conversion factor. So pi is in my numerator, but it needs to go away because when I put it in degrees, there are no pi's in my answer. So pi needs to go away, so it needs to go in the denominator. Pi is the same thing as 180 degrees. So therefore pi goes away, and now at this point it's just a matter of multiplying. 13 times 180 degrees divided by 18. And then you still have your degree unit left. So 13 times 180, and then dividing it by 18 is 130 degrees. 13D number 8. We have negative 2 pi over 9. The first thing they're asking us is to convert it into a degrees, into a different unit. Negative just means the direction we are rotating. This means we rotate in a clockwise direction. So if we're converting it, we are converting to degrees, which means we want pi to go away, so it has to go in the denominator, and 180 degrees is the same thing as pi. So therefore my pi's cancel, and I have negative 2 times 180 degrees divided by 9. So if I go through that, then that comes out to negative 40 degrees. So negative 40 degrees is the same thing as negative 2 pi over 9. Negative 40 degrees, that ends up in quadrant 4. Okay, these just show you which way you're rotating. If that's 0 degrees, going down and rotating that way, that is negative 40 degrees, ended up in quadrant 4. That is also the same thing as, right here, this is also the same thing as 2 pi over 9. That negative tells me I'm in quadrant 4. This negative tells me here I'm in quadrant 4. Okay, this is how a radian measures can be applied to real problems. So if you look at this circle, then from the center of your circle to the outside of the circle is your radius. And then if you had another line here, then the angle, we're going to call that theta. And then the distance of this arc from this point to this point, we're going to call that r. So lowercase r is the arc length from this point to this point. Okay, so you can make this equation here, this relationship of the two, that theta is equal to the arc length divided by the radius. Okay, one of the main key things to know is that theta for this formula cannot be put in degrees. It has to be put in radians. Okay, theta has to be in radians. And then this is the radius, lowercase r is the arc length. Okay, so looking at 15D, number 16, they're asking you to find the distance between two cities, and we're going to be using the radius of the Earth as 4,000 miles. I believe that this is a rounded value, but we're going to be using that value for the radius of the Earth. Okay, so we're told that Anchorage, Alaska is 62 degrees north and that Tahiti is 18 degrees south. So let's just draw a 2D picture of the globe. So this center line here is like the equator. So we're told that Anchorage, Alaska is 62 degrees north of the equator. So we'll make that, we're just estimating that. So that would be Anchorage. That is 62 degrees north of the equator. Okay, then Tahiti is 18 degrees south of the equator. So we'll do that estimate there. So there's Alaska, there's Tahiti. Okay, this is 18 degrees. They are wanting us to find the distance between these two cities. So we are going to be finding that arc length in between those two cities. We're going to be finding r. So we're going to use this formula of theta equals the arc length divided by the radius. Well, this is the Earth, so the radius is going to be 4,000 miles, and then we're going to do theta, but we're going to put it in radians. So if we had this picture here, this is 4,000 miles, that's our radius, and then, well, let me redraw that. Here's what we have. We have this, and then this. I've exaggerated a little bit. That total angle is going to be the 62 degrees plus the 18 degrees. Okay? So that total angle there, 62 and 18, should be 80 degrees. Okay? Then we can find the distance, or that arc length, which is lowercase r, and then our capital R is 4,000 miles radius of the Earth. Okay, so here I'm just going to write it like this, 80 degrees, but we have to put our angle in radians. This has to be in radians, not degrees. Okay, so right off to the side, I'm going to convert my degrees into radians. Okay, pi has to go here, 180 degrees here, so my degrees cancel. That's the same thing as 80 pi over 180. You can go through reducing it. You don't have to go through reducing it, since we're going to use it in a calculation, but I do know that that will reduce by 10 and be 8 pi over 18, and I can also reduce that by 2. That would be 4 pi over 9. So instead of using 80 degrees, I need to use 4 pi over 9. You could have used 80 pi over 180, and your numbers would still come out the same. pi here, we're going to use pi as 3.14. Pi is pi. So now I can use cross multiplication to solve for my lowercase r. So that'd be 4 pi times my 4,000 miles. Notice now that miles is my only units that I have in this problem. So my final answer of r will be in the units of miles. Okay? Equals 9r. So solving for r, divide 9 to both sides. So now it's just a matter of, this is 4 times 3.14 times 4,000 all over 9, and miles should be my units. So this whole numerator came out to 50,240. Then I'm dividing that by 9. So that came out to 5,582 point, I'm just taking it to 2 decimal places. So the arc length between Anchorage, Alaska and Tahiti should be that distance. Okay, now we're going to go on to 15C, number 15. Same thing, we're finding the distance between these two cities. So we're still using the same radius of the earth. So here's what I have. If this is my picture, here is my equator. So Bismarck, North Dakota is 47 degrees north of the equator. So if this was like my 0 degree line, that is almost like a 45 degree line. That would be 47 degrees. We're just going to call that B for Bismarck. Then Mexico City is 20 degrees north of the equator. They're both north of the equator. So then I have, there's Mexico, and then this in red is 20 degrees north. When they're both on the same side of the equator, be careful. Instead of adding the two angles, you need to subtract them, okay? Because here's what we have. You have a 20 degree angle, and then you have a 47 degree angle, okay? We need to know what is that angle in between. So 47 minus 20, 27. So we are looking at that, we're looking at this arc length right there. So when they're on the same side, this is the arc length we're looking for, right there, in between the two. So when they're on the same side, you need to subtract your numbers, okay? So still using the same formula, finding the arc length over the radius. This needs to be in radians. So this was 27 degrees. So we need to take 27 degrees, convert it into radians. I can leave it just like that if I want to. So I'm going to leave this as 27 pi. I don't need to go through the work of reducing it. I can, but I just know I'm going to be solving it in an equation anyway. So 4,000 miles. So cross multiply 27 pi, and I'm going to go and put in my 3.14 times my 4,000 equals 180 r. So to solve for r, I need to divide both sides by 180. So multiplying everything in the numerator, then dividing the 180 in the denominator. Came out to where the arc length is 1,884 miles. That came out to an even number.